Okay, so now we've graphed quadratics in vertex form and in standard form, and now we're going to look at the third form. All right, so the equation looks like this: y equals x minus 5 times x minus 7. So let's take a look at the equation, and let's take a look at the graph and see what we can notice. Well, I notice here that this x minus 5 kind of looks like x equals 5 if I set it equal to 0. And this x minus 7 could look like x equals 7 if I set that parentheses equal to 0. And so where on my graph does y equal 0? Well, right here on this x-axis, y equals 0. So this 5 correlates to this x-intercept, and the 7 correlates to this x-intercept. Therefore, we call this particular form the intercept form, because just by looking at it, it tells us our two intercepts. Well, that's great, but I need more than just the intercepts in order to graph this if I didn't know what the graph already looked like. Well, let's take a look of how we could determine the vertex now that I know these two intercepts. Well, because it's symmetrical, the vertex always has to be in between these two intercepts. So if I take 5 and 7 and average them, so 5 plus 7 is 12, and divide it by 2, I get 6. Now that I know my x value of my vertex, I can plug it into the original equation to get my y value. I know my a value, so once I know those two things, I can graph anything. So graphing from intercept form, it looks like this. This is the standard form of intercept form. P and Q are the intercepts of the function, and remember, because there's a subtraction sign in the form, that it's always going to be the opposite sign of what you see here. So positive P and positive Q are the intercepts of the function. So P0 and Q0 would be your two intercepts. So let's take a look at an example here. The intercepts are -4 and +2. So because of symmetry, I know the h value has to be halfway in between these two intercepts. So if I just average them, -4 plus 2 would give me -2, and divide that by 2, I get h is -1. Now that I know h is -1, I can plug it back into my original equation, just like we did when we were graphing in standard form, and I could say -1 plus 4 times -1 minus 2, and I can determine that k is -9. I know the a value because it's right here in front of this parentheses in my equation. So in this case, my a value is 1. And so now I can write this in vertex form. Again, once it's in vertex form, we know how to graph it. All right. So once again, my intercepts are 2 and 8. So I'm going to say 2 plus 8 and divide that by 2. I have h is 5. Now that I know my h value, I can plug it back into my equation. 5 minus 2, 5 minus 8. And I can get a k value is -9. Whoops, I forgot my equal sign. Now that I know that, I can just plug it in, and I have it in my vertex form, knowing that my a value is 1 from my original equation. Whoops. Sorry. -3 and +1. If I average them, I get h equals -1. Plug that back into my original equation, and I get k is -8. Go ahead and put this in vertex form. Now my a value is 2. I know that from my original equation. X plus 1, remember it's going to be the opposite sign because our formula would have a negative sign inherent in the formula. So x plus 1 squared minus 8. From here, you know how to graph it. All right, let's go ahead and try one more. The intercepts are -2 and -6. If I average those, I'll get -4. Plug that back into my equation. I get a k value of 8. I know my a value is -2, so I can plug all that information in, and I have this in vertex form. And again, now we can graph it.